Hello and welcome to another ramble. We are busy with the department's paper 1 from November 2023. Question 3.1. Given the geometric series 3, 6, 12, 3 plus 6 plus 12 plus to n terms, write down the general term of the series. Okay, so the first term is 3. The common ratio is 2, right? 3 times 2 gives me 6. 6 times 2 gives me 12. Okay, and we want the general term, so we want Tn. And we know that for a geometric series, this is given by a times r to the n minus 1. In our case, our a is 3, and our r is 2. And that is our formula. And we can just double check with one of the terms. So let's say term 3. Term 3 would be given by 3 times 2 to the 3 minus 1, which is 3 times 2 to the 2, which is indeed 12. Okay, right. So that's our first question done and dusted, feeling majestic, feeling victorious. Next question says, calculate the value of k such that the sum of 3 over 2 times 2 to the p from p equal to 1 up until some value k is equal to 98,301. Okay, and because this is a part 2 to the question, makes me feel like, okay, this probably has something to do with the first question, or our answer to the first question. So we got the general term for this series over here, the series we started out with, we got the general term to be that, right? And this kind of looks like what's going on here, except, there's a divide by 2 going on. This is a 2 to the p. The divide by 2 is going to result in a minus 1 in the power there. Then we do have exactly... Okay, so not too much tinkering required there. But yeah, a bit of a quickness with laws of exponents to the rescue. So this is the same as the sum, and let's just make it, okay, so maybe we don't need the whole sum just yet. Let's just work with this expression, right? So I'm just going to, kind of detail it, right? So this is the same as 3 times 2 to the negative 1 times 2 to the p, which is equal to 3 times 2 to the p minus 1, right? Which is the same as the pth term. Okay, so as a result, the sum from p is equal to 1 until k of 3 over 2 times 2 to the p is the same as the sum from p is equal to 1 up until k of tp, and we want that to be equal to 98,301. And we know that these is pretty much just the series, right? The sum of the first k terms of this sequence. So we want to figure out how many terms do I need to add together in order to get to this. And we know that the geometric series is given by a times r to the n minus 1 divided by r minus 1. In our case, a is 3, the first term, r is 2, n is k, and then we replace the r here with 2 as well, and we want that to be equal to that. So that is 3 times 2 to the k minus 1 divided by 1. Okay, right, divide by 1 doesn't do anything really. Okay, so now we can divide both sides by 3. So we have 2 to the k minus 1 is equal to 4. Oh, oops, not divide by 2, my girl. Divide by 3. Right, so that's 3, 2, 7, 6, 7. Okay, and then we add 1 on both sides. So 2 to the k. Okay, I'm just going to double check this division. So 3 goes into 3 times. 3 goes into 9 3 times. Gosh. 3 goes into 8 twice. Remainder 2. 3 goes into 23 7 times. Remainder 2. 3 goes into 20 6 times. Remainder 2. And 3 goes into 21 7 times. Okay, cool. Happy. Right. Add 1 on both sides. Okay. And then I'm just going to get my trusty calc and prime factorize this guy. I'm hoping it's a power of 2. Otherwise, we're going to need to use some logs. Yes. So this guy is the same as 2 to the 15. And therefore, k must be equal to 15. That is the number of terms we need to add together in order to get 98,301. So that's one way to do it, using kind of leaning on this. But if you hadn't spotted that this expression, is this in disguise, how else could you have gone about it? So let's explore an alternative way. So we needed to find the k such that this will be equal to this. All right, double check. Yes. Okay, so of course then one way you could do it is to expand the sum, right, and see what comes up. So this would be 3 over 2 times 2 to the 1 plus 3 over 2 times 2 to the 2 plus 3 over 2 times 2 to the 3, and so on until 3 over 2 times 2 to the 4. Not to the 4. To the k, right? Okay, then the next thing you'd ask yourself, is, okay, so first you could simplify each term, right? You could definitely do that. But from here, I think it's clearer to see that you have a geometric series, right? Because the difference is a bad word, but to go from this term to this term, you're timesing by 2. The only thing that's changing is this exponent. And to go from this term to this term, again, this exponent is increasing by 1, so you're timesing by 2. So you would be able to see that, okay, this is a geometric series, right, where the first term is 3 over 2 times 2 to the 1, which is the same as 3 over 2 times 2, which is the same as 3. And your r is 2, and your n is k, and you're told that the series is equal to 98,301. So then you would solve for k that way, which is pretty much where we got 2 using another route. Your a being 3, your r being 2, your n being k, your series being equal to that. So yeah, so that would be the other way that you could go about solving the question. Let's just double check with the memo if it is in agreement. Where's the memo? Memo is in agreement. What? Oh, that's another question. Okay, yes, memo is in agreement. Perfect. Thank you. Goodbye.